Before you try one of these problems on your own, I want to show you kind of a special example one right here that I think is pretty interesting that you will come across. This problem right here, again, we're trying to figure out what x and y is, and really what this comes out to be is when we figure out what x and y could be, this is a line, and we're really finding where these two lines cross. So maybe this would be it, and maybe this would be it. So maybe they cross here at like 5, -1. Okay. This is a case right here where you have two lines that will never cross, or two lines that will never meet at all whatsoever. And the reason I know that is that this is going to end up being no solution. It's going to be you can't come up with anything. And what you'll see is when I start eliminating things and canceling things out, I will actually cancel out everything here just by doing one thing. So for instance, let's say I want to cancel this out by making this -2, and then this would still be +2. All I would have to do is multiply by -2. So my new numbers are going to be -4y, -2x, and -16. Now if you take a look at this, -4 would cancel out with 4, and 2 would cancel out with -2, meaning there would be no possible solution. These lines are not going to cross at all because we're going to cancel this out, and this means we have nothing that x and y can be for both of these lines. And if I approach it a different way with the same problem, let's say I want to try to cancel these out instead, I'm going to have to multiply this by -2 to get -4, so it's actually going to be the exact same thing. -4y, those would cancel out. I have to multiply this by -2, -2x cancels out. All I have left is whatever I would have down here, and I don't have any of the x's or the y's left, so this is going to be a no solution, or if you had to graph this, it would not cross anywhere. The final example I have here is just a regular problem, and I would like this to be one where you try it on your own. I've showed you 2 ways to do each one of these. As long as you can come up with one way, we'll be fine for this. So what I would like you to do is just pause the video here, take some time to try this problem out, and then come back to the video and check and see how you did. Let's see what you came up with for x and y. So the first time through, I will cancel out the x's, and then on the next page I've got the same problem again, so I'll cancel out the y's. So in this one, probably the easiest thing to do is make these 6 and -6. So what I'll do is I will do times 3 here and times -2 here, because what will happen is this will end up being 6x, this will end up being -6x, so these are going to cancel out. But we also take care of the rest, multiply all this by -2, multiply all this by 3. So this is going to be 27y, this is going to be -10y, and then this would be -2 times 17 would be -34, and then 3 times 0 is still 0. So now the numbers we're looking at are these 3 and these 3. These will cancel out because it's 6 and -6. If I put 27y and -10y together, I get 17y equals, and then 0 and -34 is just -34, and 17 times -2 is -34. So I'll start my coordinate here, x, y, -2. Now I had to put -2 in for one of the y's somewhere, so it really doesn't matter which one you do. So I will just come back and do, how about this one right here? I'll do this one. So we have, oops, maybe I should do a different color here. So I have 2x plus 9 times -2 equals 0. So if I simplify that, 9 times -2, and I just put that -2 in because that's where the y was at. Let's simplify that to -18. Now my problem is 2x plus -18 is 0, so I'll get rid of this -18. I'll add 18 to get rid of that. I'll add 18 over here. So now I'm left with 2x equals 18. So x has to be 9. So your answer for this one should be 9, -2. Now, if you did it a different way, I'll try to cancel out the y's for you if you did it a different way. So let's see, 9 and 5. The smallest number I could use is 45. Yep, 45. So I'm going to make one of them negative and one of them positive. So it doesn't really matter. I'll make this one negative. So I'll do times -5. And I'll do multiply by negative. Nope, I don't want a negative there. I want to keep that positive. So we'll just multiply by 9. So we'll go through the whole thing here. That would be -10x. That would be -45y. And that's still going to be 0 because -5 times 0 is 0. Down here looks like I've got 27x. Looks like I've got 45y. And then 9 times 17, I'll have to get that. So that would be 90 plus 63, which would be 153. So now we just have to go through and actually cancel things out and see what we have left here. So I'm looking at this, that. Cancel out, cancel out. So now let's do this. We've got 17x equals 153. That's what I have over here, because if you add it to 0, it's still 153. So we have to figure out what x is. So I'm just going to take this and divide by 17 to figure out what x would be. So if I do 153 divided by 17, I get 9. So x equals 9. So in my coordinate over here, I've got x, I've got y, I've got x being 9. So now I have to figure out what y is. That's a good thing because we got 9 over here too, so that was good. So this should be -2, but we'll figure it out. So I will do this one again. So we're going to have 2 times 9 this time because x is 9 plus 9y equals 0. We'll simplify that. 2 times 9 is 18. Okay, I'll get 18 on the other side. So I will do -18, -18. So now I have 9y equals -18. And 9 times -2 is -18. So our point crosses at, or our two lines cross at 9, -2. That's where they would meet at. So this was your introduction on elimination with systems of equations. Again, if you have any further questions, make sure you let me know.